Alright guys, I want to talk to you about something new today. We're going to talk a little bit about a different way to measure angles. So up until now, you've learned about degrees to measure angles, which is good. However, there is a whole nother way to measure angles. It's called radians. Now, this has to do with measuring angles in circles, although it can measure any angle with it, but it really has its usefulness and its basis in measuring angles in circles. So, what one radian looks like. This is the amount you have to open the central angle in a circle to make the radius and the arc length out here be the exact same length. And so you open up this angle to where you get to this radius, or this arc length right here, being the same length as the radius. That's 1 radian. And so I like to bring up this question with this. It really lets us see if we understand what's going on here. So how many radians are in a whole circle then? Well, if we have to open this up to where there's 1 radius out here, 1 radian makes the radius be out here, it's really saying how many of the radius do we have to put together to get around the whole circle, which we actually know the answer for, because we know how to find circumference of a circle already. We had a formula for circumference, which was 2 pi times the radius. This actually tells us how many of the radius it takes to go around the outside of a circle. And it's not a super nice number. The number of radii it takes to go around the outside of the circle is 2 pi of them. So how many radians would be in a full circle? Well, we have to open it up to where we have enough of the radius put together to get the full circle, and that's 2 pi of them. And so there's 2 pi radians in a full circle, which is about 6.28 approximately is how many radians. It can't be exact because unless we leave it as 2 pi, because pi is irrational, it never terminates or repeats. And so basically we can just say there's 2 pi radians in a full circle. So 2 pi radians would be the same as 360 degrees, in other words, because they're both representing a full revolution, a full circle. So the big application of radians, we've already talked about how to find arc length when the central angle was in degrees. We're going to talk about how to find arc length when the central angle is in radians now. So I've got a couple different things going on in this circle over here. I've got a 1 radian angle right there. And in this one, instead of just saying r, we actually have a measurement in here for the radius. So the radius is 10 feet. Now, if this is 1 radian, think about what we said over here. If it's 1 radian, the radius is the exact same thing as the arc length, which means this 1 radian angle right here would make this arc length right here the same as the radius. So the radius is 10 feet, which means that arc length right there is 10 feet. Now, this angle right here, this larger angle, going out to that like red arc out there, that angle is 3 radians. So if we're going 3 radians, then basically we have 3 of the radius put together to make it around this thing. And so if that's the case, if we have 3 of the radius and the radius is 10, that arc length would be 30 feet. Now, I'm hoping that you guys are starting to see a pattern here. So if I do 1 radian, it would be 10 feet, 3 radians would be 30 feet. If it were 2 radians, it would be 20 feet. If it were 5 radians, it would be 50 feet. Basically what I'm doing to come up with these lengths, since each radian makes 1 radius out here, I'm just doing the angle in radians times the radius. That gives me the arc length. And that's the general formula for how we get the arc length. And I put it in parentheses here for s because the variable we use for arc length really often is s. And so the way we do this is the radius times, and I'm going to say it this way, the angle in radians. So the radius times the angle in radians is how we get the arc length. And if you notice, if you think about what we did before when we were finding arc length, we had to set up like a whole thing where we had to first find the whole circumference, and then we had to figure out what fraction of the circle we were using out of 360 and multiply the circumference by that fraction. So it's kind of a long process. For radian measure, it's extremely simple. We literally just multiply 2 numbers together, and that's the arc length. And that's really why radians exist. is because they make finding arc length a very simple application, or a very simple way to do that. All we have to do is multiply two numbers together. It's really simple to do. It's a simple process, whereas if we do it in degrees, it's a much more complicated process. So let's see if we can put this to use on an example or two. So the big thing we found out is if we want to do arc length, we do radius times the angle in radians. And so I've got an angle here on example 1 over there. We have 2 pi over 3 for the angle. So that's the angle in radians, 2 pi over 3 radians. And the radius on this circle is 6 inches. And so if I want to find the arc length here, then basically, and I'm going to call it S for arc length, we would want to do the radius 6 times the angle in radians, which is 2 pi over 3. And so there's a couple ways you could go from here. You could leave everything in terms of pi and just try to do it like that. So 6 times 2 is 12. 12 pi over 3. 12 over 3 is 4. And so this is going to be 4 pi if we put it like that. Or if you want to get it as a decimal, if you're doing this for some practical purpose and you want to know the distance around there, kind of like the belts on a pulley problem we did the other day, then you would probably want to know this as a decimal. And so I'm going to figure out what this is as a decimal here. And that would be about 12.56 is what that would come out to. But I'm going to round it up to 12.57 if you use the pi button. If you use 3.14, it's 12.56. And since we're doing length, this isn't area or anything, right? It's just distance around the outside of this thing. And so its length is just regular old inches. And then let's try one more. What is the length of an arc in a circle with a diameter of 32 inches that is intersected by a central angle of 2.38 radians? I wanted to do one like this because basically a lot of times there's questions like this on standardized tests, ACT, things like that. A lot of words. But really in the end, we know the angle in radians, right? We know the radius with a little bit of work. We know the diameter. So let's take this one step farther and let's figure out what the radius is. If the diameter is 32, the radius is just half of that. So the radius on this is 16 inches. So we know the radius, we know the angle in radians. So to find the arc length, which is what we're supposed to do here, we do the angle in radians multiplied by the radius. That's it. And so this is really just to find the arc length. 16 times the 2.38 we have for the central angle, and that's going to give us the arc length, which gives us about 38.08. And so our arc length here is 38.08, and since that was in inches, our arc length is 38.08 inches. And so the big thing with finding arc length, if we have an angle in radians, the arc length is really just the radius times that angle in radians, and that gives you the length of the arc.